Hello, everybody. My name is Barnabas Nomo, and welcome to Yada Yada Electronics. Today, we're going to be building an interesting project. It's quite mainstream, and it's, I think, one of the early beginner projects that people getting started with the Arduino work on. And that's a way to take, a few digital I/O lines and control like 16 LEDs with it. So we're going to have an array of 16 LEDs coupled with two shift registers, 8 bits, shift registers, and we're going to design them, like the schematics. Then we go from schematics to building a simple PCB layout. And we'll build one unit first, then we'll add a single unit, we'll add the second shift register. Then we will place items and look at the different ways that you could do PCB routing. So without much ado, let's look at the kind of circuit we'll be working on today. So this is what we'll be working on today. We'll have our Arduino Nano, and this is a breadboard version, and really if you can build anything on a breadboard, then you can kind of easily make a PCB. When you add radio modules, things become a bit more complicated, but for the most part, you shouldn't have much of a problem, I guess. So yeah, we're going to place our Nano first, then this module, the shift register. Then you can see 8 LEDs per shift register. So we'll place one Nano and then one shift register, then 8 LEDs. Then we can repeat the process. Okay. So to do that, let's go back to our let's go to EasyEda and let's get started. All right. So this is a circuit that I had. I'm just gonna remove this. And what you do is you go to File, New, Project, and you can save the project as anything. So I named my Yada Yada Lesson 01 LED array, right? And when that page loads, you can just come here and just name it LED array. Your company, you can name it whatever. Speaking of companies, this summer my friends and I are launching a assistive mobility company, so I'm really excited, even though I don't look like it. So yeah, let's place our first component. So you go to library and let's go here, LCSC electronics, then you can search the parts, right? So HC 595, right? So let's place the components, one of each, then we'll just start working our way down. So this is a small circuit, so I kind of know all the things we need, and so we can just place them and then go on. So we'll go with a D package, and there's this variant that I found earlier. It's quite cheap. It's not the cheapest, but it's the most abundant. So if you're probably following this tutorial, you might want to use this, right? And so that's why I'm using this footprint. And also, so what I do is usually I'll copy this LCSC part number here, then I can come here, with a search engine, I'll go back to EasyEda and I enter that, right? It's also already here. Select this and I can click place. Okay, so the reason why I do that, even though I could have just clicked place from here, is because sometimes you can see how many, the minimum order quantity, right, or MOQ, and the price, and so you can just, and then if it has a PCB module, you see it here, so you can just go ahead and click place, and you place this, right? Then let's go ahead and what's it called, place our Arduino Nano. So for this, we keep our search engine at EasyEda because we're just going to have our own Arduino Nano, and we'll just place it. So this is how it's called if you want the header, and click this, let's place, boom. Then another thing we're going to do, so if I bring up the breadboard module again, right, this is what I have. So all these resistors, are 180 ohms. So we're going to place one resistor, we'll place one LED, and I guess we can just do copy paste. Okay, so go back to my EasyEda, and let's go to library. Let's go to LCSC electronics, scroll down till you see resistors, then you select chip resistors, surface mount, and yeah, so let's come here, select the footprints you want. Hold on. So let's select the footprints we want, and we'll select the value of the resistance. That's 180 ohms. So you scroll down, they sorted by resistance for you, so you can just scroll down for a while until you get to the so 180 ohms. I think what would really be handy is if they had a simple search bar here. Oh, really? They do. I never knew this. Okay, so that's it, 180 ohms. And apply filters, right? So there's one here from Panasonic. I think if you click this, they would probably tell you it's not in stock, or even if it is, it's too expensive, right? So let's go ahead and just go, with this variant, right, from Uni Royal or Uni Ohm, and you can just click place here, or you can go to EasyEda and place. So let's just click place here, because now you know how to check for minimum order quantities. So I think for this you can order a minimum of 100, and yeah, but don't worry, if you do the math, it's not that crazy. So this is R1. Let's delete this 180 ohm, and we can just place a note here that all resistor values are 180 ohms unless otherwise specified, right? So let me just make a few mods here, change the font size to like maybe 4 points, because we don't really need this. If you are designing for somebody else, you probably shouldn't make your text very small, because there could be some really important information you're missing. So let's place an LED as well, and to do that, we go to optoelectronics, still under LCSC electronics as the search engine, 0603, apply filters. We'll use the first one that comes up. And okay, so there's a Everlight electronics. I guess there are different modules, and this one doesn't really return like the cheapest. I don't know how the algorithm works, but if you really want the cheapest, you go click LCSC parts and still use the same thing, and there's an option that allows you to sort by price. So let's go. I think maybe after the tutorial I'll probably sit down and try and find the cheapest that you could use, so that you don't spend too much following this course outline. So let's place this LED as well, right? And I just removed the label, but there'll be like a bill of material, so if you want the label, that'll be fine. All right, so let's place our ground and just hook up all these LEDs and resistors, right? So I'm going to select this, and this. I held control, so click one, hold control, click, and then click another, and control C. So let's paste it. I hit X to flip it around, and boom, right? Then let's do the same for X to flip around, X to flip around, X to flip around, X to flip around, X to flip around. I mean, you get a point. So we have that over here. Then let's place a ground line. Okay, so now let's just connect all our grounds. I think that's usually what I do first, but yeah. So you click ground, and the way I rotated it was by hitting R. Okay, and let's go up to our Arduino board. Place ground here. Place ground here. And let's connect our VCC line as well. So VCC. And for the main part, okay, then this other VCC, you can also hit Control Q to bring up VCC and Control G to bring up ground. Right now, there's this pin here, okay, and this is, we call it G. I guess G sharp is that a key, I guess so. But let's go to our module again, and I downloaded this data sheet for this module, so you can tell that it's not really SNHC SN74HC595, right? It's this module over here, and it's like from a Chinese manufacturer, but I used Google Translate to get the English version, you know, and it's a 8-bit latch, 8-bit serial input, 8-bit serial parallel output, you know. I mean, and they call it a general purpose LED driver chip, right? Because it's really mainstream for that. So what we'll do is this. Okay, so I mean, this is really the same as like a purely English version of the data sheet, so let's just go with this one. And we have Q0, Q1, Q2, Q3, right? These are data output lines. We've already done that. Then for output enable, you know, it says active low, and what active low means is that that pin will be like will be active if you give it a low, right? And it will be like not active if you give it a high, I guess. So and what happens is, you know, if you see a bar here, you know, in digital electronics, a bar just means something has been flipped, like it's inverted, right? So you send it a low and then it becomes high, right? So let's just connect that to ground for now. And then there's a master reset, which is active low, but we don't want the board to reset, so let's put that to high, right? Let's put that to VCC. So we'll come back to our module, and we are going to go ahead and place we're going to make, since this is active low and we are doing output enable, so that'll be output, right? And then our master reset, that's SCLR, this is it. So this is pin 14, you know, it's our serial data inputs, and that one I think the popular design that everyone makes, they put it on pin 8, right? So we could just go ahead and do, you can call it ES, or you could just call it SCR, you know, serial data inputs. And let's go here, same thing, hit X to flip around, place on pin 8. And this port, the reason why we're doing this port is because we don't want to come like draw a line all the way here to here, right? So you use a port and it's like assigning a variable, and that same variable is here, right? More or less, it's like a label, really. So RCK is really what we call the shift register clock input, is it? No, that's the storage register clock input, right? That's the storage. What does the storing of the data? So I mean, it's synchronous communication. That means a clock pulse must be involved, right? So that's what we're doing. So let's put RCK would go to our pin 9, and then CK will go to pin 10. And so just do this. Name this RCK. Then this, I guess the only thing that changes here will be the SCK, right? And let's go place this, you know, and we'll change this to RCK. All right, so With that done, you can hit K to like center everything. So if you're working and your sheet changes for some reason, you can just hit K to recenter it. And we have this simple module, right? So what do you think the addition of a second shift register would look like? Think about it, and we'll get to that in the next video. Thank you.